So, hello everybody. First of all, I'm certainly the opposite of a professional speaker. I will try to be fast with all of this so that we maybe have time for questions and discussion, because I think there is a lot of things one could possibly discuss here. And let's start with my presentation today, which is about PHP and Go, which we found to be a success story. I'm the co-founder and CTO of Best Bytes in Munich, and here's a short list of things I like to work and play with. But today let's talk about gophers and elephants, and that is the gopher, of course. So those are the two mascots. Apart from that, the mascots are very different. PHP and Go are profoundly different in almost every single respect. So it's compiled versus interpreted. It is statically typed, strongly statically typed versus dynamically typed. It is highly concurrent versus a single isolated share nothing process model. It's long living versus a per request model. And it's different in a lot of other ways. So PHP and Go are complementary. They're not only different, I would like to say that they're complementary. And so why not use them together? For us, combining the both has been a success story. And I would first like to start with a comparison of the both, where I just walk through the essential characteristics of both languages. I will talk about the languages, the runtime model, and the development process and experience. And then I'll try to show an example, typos related, NEOS related. So everybody knows that. I'll go through that one quickly. PHP is dynamic interpreted. It makes everyone a developer, right? Everybody can develop PHP, for better or for worse. It was not designed too carefully. Despite that, it's highly productive and pragmatic. And let me quote Rasmus Lehrdorff, I don't know how to stop it. There was never any intent to write a programming language. I have absolutely no idea how to write a programming language. I just kept adding the next logical step on the way. The PHP web application lifecycle. So PHP lives in a per request lifecycle in or behind a web server. The client calls the web server. The web server decides if that call is a call where it will call or run a PHP process or not. So you won't see all the calls when you're writing a PHP. The PHP process then runs interpreted. It runs as one process. There is no shared memory, and it is blocking. All the Node.js guys will go wild on this one, right? The PHP web server interaction is quite limited. There is an inconsistent small API to interact with the web server, where you can do things like sending headers and, of course, stream output data. Well, and once you're done, your PHP process is done. Which is not too bad in many cases. Let's review that. So what does that mean? First of all, PHP is, I would say, the home of the save file page reload loop, which is something, now, I don't know how many of you, actually that would be something I would like to ask, how many of you are working with languages like Java or C# or other systems where you have a build process that takes more or less long? Huh? Okay, so I'll bore you guys, but you know how valuable it is if you just save that file and you reload, and you can see what effect your changes had. Of course, on the other hand side, compiler feedback can be tremendously valuable as well. But once again, I can't stress this enough. This is fantastic about PHP. It's really fantastic. Well, this life cycle is simple and comprehensible. Pretty much everybody understands it right away. The code is interpreted with every call, so no compiling, feedback right away. And by nature, what you're doing here is pretty REST-friendly because, well, it's actually relatively hard to create state in a PHP application. Also, if you do something really wrong and your PHP process goes away, so what? The next call might work. So what is the criticism here? It's relatively limited. If you want to build something, you want to build a chat application where things automatically get dispatched and you don't want to poll, so clients support those WebSockets. Those are almost impossible to do in PHP without some brutal workarounds. And also on the bad side of things, well, code needs to be, even if it's opcached, it needs to be loaded back to memory, and that, of course, has a performance penalty. And server state is hard. PHP development. Everybody can be a part of it. I already was talking extensively about this valuable page reload cycle. It's very forgiving. Until you hit the wall, right? So who knows the WAD talk? Okay, he knows, he's laughing. You should look it up. Maybe I'll tweet it later. So, there are cases where you need the equals operator in PHP if you don't want to run into some very unexpected errors. So there is the boxing of variables. You can mix strings and floats and doubles and whatever, and it won't break anything in the first place, but it might lead to very unexpected results. But it can have, when you're in a template and you just want to print things, that's fine. PHP tooling today is nothing short of fantastic. It's a huge market, somewhere between PHP Store and Zen Studio, but also like Sublime, Vim, whatever. You will find, and I don't need to tell you, it's fantastic. Well, sometimes we wish, especially in large projects, if there was a compiler. There are things like mess detection, there is static code analysis, and that helps a lot. But still, sometimes you really wish it was there. And we were talking about the design of it before too. Now, what is Go? Go originally came out of Google, and they developed it there to replace Java and C++ for large performant server applications. Today, like concrete use cases at Google, if you download either Chrome or something in the Android SDK, the server that is serving that is actually is a Go application, and it uses the standard library web server, which is fantastic. The main things they wanted to fix in comparison with Java and C++, first of all, were build times. That was one main focus, and you hardly ever wait on the compiler when you're writing a Go program. They took some quite radical decisions, especially when designing interfaces. There is no polymorphism, there is no exceptions. And when they first presented the language, there was a lot of criticism, especially from the language design camp. And it probably received it mostly because it was so radically simple. And people were saying, yeah, but come on, where is this, where is that, and so forth. And they kept very strict and didn't adopt a lot of features people were asking for, and now slowly people are adopting it, and there is some very, very impressive software being written with it. What is also to mention is that there is some, well, Google, obviously they have huge resources, and they got some great people into the design of the language. So do you know who Ken Thompson is? Yeah, so you know who Dennis Ritchie is. So, okay, now if you will look for an image with Dennis Ritchie on the internet, probably the guy next to him is Ken Thompson. Okay, and they have some other people in that team who were very much involved in the development of Unix before Linux, and it's just incredibly experienced people. And when you start using Go, you start getting the grip of that pretty soon. And you know, first like, okay, why is that like that? And then you start using it, it's like, and it starts to feel really nice from the experience point. Also important to say, it's, I would say, you know, big companies, do you want to, I mean, what is great about PHP? Yeah, there's Zend, and but still compared to other languages, it's really an open source thing. And I think Go is on a good way into that direction. Quickly through the list, it is strongly typed. It has a really strict compiler. It's quite close to the metal in every respect. Still, it will manage memory for you, so you don't need to care about that. The standard library, which I shortly mentioned in regard to the web server, is fantastic. No matter where you look there, it's fantastic. It's really, really good. Also, the community as a whole is high quality when you look around and see what code is written and shared. One of the main points about Go certainly is that writing concurrent applications that scale and are really fast is easy. It's really easy. And what is very nice, when you compile your application, what you get is a platform-specific binary, one binary. Now, in a typical web application, the size of that binary will be something starting with a few megabytes to maybe a few dozen megabytes, depending what kind of things you do. And but it's certainly, like, you know, more in the range of one a set in some websites. And that is your server or whatever you do with it. And well, if you have the right architecture, you just copy it on your web server, or you run it on your local machine and it just runs. The Go web application lifecycle. Well, you are the web server, so you can do whatever you want to do. And the code that you've written will be executed concurrently, which is a huge, very interesting topic in the way they implemented it there. And your memory is shared. So it's not interpreted. There is no per request overhead when you now look at the web server example, which we do in this case. you can do pretty much whatever you want, as I said. When you're running as a web server, you can really get down to the SSL handshake if you want to, or need to. And, well, on the other hand side, with great power comes great responsibility. You might run into things there that PHP and your Apache stack hides from you in a good way. Go development, as I mentioned before, the compiler is extremely fast. So compare it to some other build processes in other languages. And I didn't read it before, but you might have seen the quote from Rob Pike, who originally had the idea for Go, supposedly as he was waiting for a C++ program to compile. There's no C++ programmers here, or? Were you laughing? No? Crying? How long do you typically wait for a program to compile? Starting from 2? Like invent a programming language. Well, not everybody can do that, I guess. So, it's really incredibly fast. They have strong and well thought out conventions all over the place. So, there is a way how you lay out your code. It comes with unit testing and benchmarking. And there is a lot of tiny tools. So, for example, you know, it's always in a programming language, shall we use tabs, spaces, how are we going to format functions and if statements and loops and so forth. This discussion doesn't exist in the Go community because there is a tool, it's called Go Format, and it defines the way a Go source file is formatted. That's it, no discussion. I think that is nice and pragmatic. And coming down to the tooling, so I am, for example, using Sublime when I write Go code, and you know that with other computer languages, now you know all the advantages of Sublime. It's lightweight, it's beautiful, it's fast, or Atom, same thing. But in many cases, you certainly won't get so much out of it like out of IntelliJ. But the way they built the language tools and did that very early on, you get very meaningful code completion and error hints in, for example, Sublime or Atom or Vim or Emacs. Yeah. Let's talk about the bad parts too. So the Go community right now is really struggling with package dependency versioning. So there is a lot of people from the Node.js community making big fun of them because they solved that pretty well with NPM, and they're really struggling with that and trying to get that one, but I think they're gonna do that. The next thing is debugging is surprisingly disappointing, and as far as I understand the reasons for that, it has to do with the way those Go routines work, which are the mechanism to do concurrent and parallel computing in Go. And they simply don't quite match the typical C model, which all the debugging infrastructures in the operating systems are based on. So that, unfortunately, as I said, is not where it could be. So, things get more interesting when you have something to look at, something concrete. And in our case, we have been working with PHP content management systems for more than a decade, and one problem kept coming back to us. There's content trees, and there are those large nested data structures. They can have many dimensions like regions, languages, media-specific rules, personas, groups, and many, many others. As you know, there is a lot of customers who have very interesting problems, and probably each of those problems is going to add another factor or dimension into your content tree. Obviously, this is the most important part of your website, and they need to be in a safe place like the Typo3 CR or in another system that can store such data. And as we also know, safe typically is the opposite of fast. So they might need some time to get out of there. Is that a problem? For small sites, typically not. The first request is, I'm just making an example here, might be something like below 500 milliseconds. You cache it, the next request comes in, everybody's happy. And Neos does a fantastic job here. But at some point, this construct gets cumbersome. And that happens when that first request, when the caches are not there yet, takes too long. Now, taking too long is a very different thing to different people. If you think that most customers need their website to be ranked well, that time is defined today at about 200 milliseconds. And that is hard to do. And when you have a web page with 1,000 pages or notes in 10 languages, there's 2 personas or markets and 2 device types that you want to do something fancy with, and you assume that, you know, your magic number just wasn't met, no matter if that is 500, 200, or 1,000 milliseconds. What you will get at the end of the day is this big number. 20,000 seconds, caching a whole website, that's a few hours. Well, you can do that in parallel. You can write cache warming jobs, and you can handle that. But you start finding yourself in a place where getting traffic, sudden traffic, or losing caches might be something you don't really want to experience. How many of you know that problem? Okay, it's important to me. Thank you. So, well, where's the problem? Why is that hard in PHP? Because at the end of the day, those safe content repositories I was talking about, as a matter of fact, they don't need forever. You know, you can iterate through that whole tree within a few seconds. So what's the big deal? The big deal is the runtime model. You need to do it for every single request. And there you are. You're stuck with caching and background cache warming jobs and ugly calls from customers because the website froze, because God knows what. So we took a step back at some point, and we thought, what if there would be a daemon that would load that data in the beginning? Now, as I said, big repository. You iterate through that few seconds, half a minute maybe, but no big deal. Because you just do it once when that thing starts, and then maybe every now and then you tell it, okay, now update. Now, to make things simple, to create something maybe reusable, we defined a simple JSON schema, how to describe your data. I know that is in conflict, seemingly, with all those different types of projects. If you have questions on that, come to me after the talk. But essentially, the thought is, you have that running daemon, it has the data loaded, and then from your PHP process, you start talking to it over a socket API, essentially with something like JSON RPC. And since it's a program written in Go, you can do that concurrently, actually highly concurrently. And because of the memory model of Go, you share that memory, and that's perfectly fine in this case. No more caching. So why did we choose Go? As it turns out, we actually wrote a first prototype with Node.js, and the reason why we dropped that one was, well, you load it into memory and then you can do one at a time. Also, it's not so fast. And if you would want to maybe fork, that would work. If you would want to start worker processes, you would have to put everything in there. It would be slow again. So the core are those Go routines that run in parallel, that share memory. The sheer performance of Go, it doesn't need to box things because the compiler made sure that not some complete wrong thing was declared. So it's way faster. And also, once again, because of the boxing is missing and because it's platform specific, the memory footprint is very low. Also, deployment is nice. You just copy that binary, you're done. Why did we choose Go and not another language? Well, we've been looking at some languages, and to be very honest, there was also my personal preference how I liked Go. But we started, as I said, there was a working prototype in Node.js, and the memory model there was wrong for this use case. You can certainly solve that problem or use this, if you want to call it a pattern, with an application that will run on the JVM or CLR. It will certainly be fast enough. You have the capabilities to thread and access memory in a way that would allow you that. Meh. No offense. I also looked at Rust. That looks very, very interesting, but I thought it was too early. And not for me. C, C++, not for me. I know there's other languages too, but you can certainly do that with a lot of languages and platforms. Some implementation details. So, there is the number of lines of code we could remove on the other side, which was way larger than the number of lines it took us to do this implementation, which is about 1,000 lines, and that's with blanks and comments and everything. And I think it's always a good sign when you do something, it works, it performs well, and the amount of code and work that you had to put into it was very, very low. The Go team is claiming that Go is so simple that you can catch up with Go development. They're saying 2 days. Put in a week and you will get something interesting. I'll mention it again, the standard library is fantastic. And as an example for that, what may work in this case very productive and easy was the framework or the standard libraries, JSON encoding and decoding. So if you have ever encoded or decoded JSON in a language like Objective-C, which is also more or less statically typed, just no comparison. But that's not about the language, it's about the APIs and the libraries that are there. So how does it look for you when you, as a PHP developer using that content server? There is 2 big steps that I want to mention separately. So the first one is exporting the data into the content server, and the second one is fetching the data. usually, that, like if you go the regular way and query your content repository, there's one step. You load the data from there, cached or not cached, and then you start doing things with them. The interesting thing about this separation is that you can very carefully think how you want to prepare the data that you are exporting, how they're going to work well in the way they're going to come out again. And the good thing is, since this is not happening as a request is hitting your website and it's only like once for the whole site, you can take time for that. This can run seconds, maybe even a minute. That doesn't matter. What is important is that the data are stored in such a way then in the content server that when you're fetching them and doing things with them, that they're just right to render your navigations or whatever you want to do with them. So at the end of the day, you need to transform your content tree into that JSON schema. And obviously you don't want to do that once. You want to do that more often, and you can do that. You can talk to the content server through its JSON API and say, okay, here's an update, and it will update in the background. So while you're updating it, it will still respond in the same speed and performance to the incoming requests, and then it will just switch, and your new content tree will be in there. Also, a very, very interesting concept which we also used in some websites, and actually not too few, you don't have just one content management system, but you have, there's a blog system, and then there is a good content management system, and then there's maybe an old content management system that is still hosting like a part. And you can mix, you can use this step to mix them all together. And what you're also going to do there, you're going to create the URIs, the links for your nodes. And it works very well. When you retrieve the data, it's a very simple little PHP API, as I said, through sockets. Essentially, you query it with a URI. So you get your request URI, you pass it in. You also add the content trees that you want to have to your order, which is like, okay, here's the URI, and I want to have that node for my top navigation, for my footer navigation, and my left navigation. And what you get back is a status. Was it resolved? Was it not resolved? Some content data. You can actually really add some anonymous data in there. It might be useful to you when you want to render it, when you want to delegate. What render engine am I going to use, or is it maybe something else? Is it an application? And there might be data in there you want to put in there to pass into that application. And you will get those navigation trees. What you typically also do, what we typically do is we then just use IDs in the documents. So you render the document, and then you replace the IDs that are linking across the place with the URIs, and you will have to ask the content server for that because he knows. So that was the content server. We find it to be an interesting pattern, especially for large websites with big trees. It was tremendously helpful with us. We presented the page yesterday, shield.ch, among a few other pages that we've made in the past that are running with it, and there is no caches for the navigations whatsoever. It was very relieving to do that. If you are asking yourself, well, how about doing different integrations between PHP and Go. There are other ways to do that, and also what might your motivation be? It turns out different people prefer different programming languages, and as much as different tasks are tackled in a better way with different technologies. And PHP is fantastic, fast, productive for a lot of tasks, and Go is for others. And you will get different people that prefer to work with different languages. And you will find that over time, some people on your team, you know, start to be a little unhappy at certain points. And now it doesn't matter if that is Go or if it is other languages. It might be very interesting to think, how can I bring something into the stack? Of course, this is also a delicate topic because you don't want to fragment your stack and your team, but it can be very interesting. In general, in general, what can you do? So you can write REST services that are pretty independent and run just somewhere, and it doesn't matter if they're written in whatever language. You can do it with RPC, you can execute command line programs, you can communicate through sockets as we did. And another, I think, very interesting pattern, as a matter of fact, I suppose a lot of you are working with proxies, be it for load balancing, be it for caching, for static file serving, to protect your LAMP stack from too heavy traffic. And it turns out that if you write a proxy in Go, the number of lines you need to do that is probably very close to the number of lines you need to configure a proxy, be it in Apache or in Nginx. It's because the standard library does has it built in. And that puts you in a very interesting place, because one of the standard PHP problems that we have, I was talking about non-blocking. So you've all heard Node.js is absolutely fantastic because it's not blocking, right? It just pumps things through and is not standing in the way. And just imagine, for example, you're having a website and you're doing some fancy image manipulation on the fly, and you're doing that with PHP. And you did it fast, you're caching it, streaming it pretty quickly, but there is one problem. Your client is slow, right? You know, there's those stupid mobile devices and people sitting somewhere in the back country on an edge connection, and they want to see that website, and that image will stream for 1, 2, 3, 4, 5 minutes. Now, if you do that with PHP, your PHP process is blocked for that time. And for example, if you put Nginx in front of it, that won't really help, because Nginx is built to be working asynchronously and not to suck up any memory. But in this case, you might say, no, that's exactly what I want to do, and that's something you can implement there extremely easily. Like say, okay, there comes the request, PHP, here you are, suck up the reply, store it and have it in memory, and let the PHP process terminate while slowly streaming things out to the slow client. What you, apart from the obvious things, also can do is you can hijack routes. You can just hijack a route where you, be it a REST call that's almost too easy. You can also go into an application and say, this is really complicated, and it's like some extreme business logic that we would need to do, and it's really slow in PHP. So you just take this one, you refactor it, write it in Go, leave all the presentation stack on the PHP side, just intercept that call with the get variables, the URI that came in with the data that were posted in. You essentially do the controller work there and then post the model into the PHP application and render it there. In concrete, how did things work for us? This is in a quiet moment, but still you will get the picture. So this is Apache. We're using mod PHP with the PHP processes in it. And you can see they take a gigabyte of memory, and that tiny little layer up here is not a border, but it is actually the memory consumption of the content server, which at this moment is at 25 megabytes. And a similar thing you can see down here with the top CPU consumers, where you just see it. And thing is, those processes run extremely reliably. That thing just has been running for months. On another system, I think we had it running for a year. They don't cause trouble. They are very friendly to your resources. And what you also must not forget, the CPU consumption on the PHP side also dropped dramatically because it's not doing a lot of things anymore. Well, it's not true, but it's doing way less than it had to do before. I would have an appeal, and that is, leave your comfort zone. If you are not some of the guys that already know statically typed languages, learn one of them. Doesn't matter which one, you will find that even if you just tinker with it and go back to the language you've always been using, you will be a better programmer in that one language. And you know, I understand that if you are a core typo 3 developer, of course you want to keep the stack consistent as much as you can, because that has a huge impact on how things are going to be installed. I absolutely understand that. But let me tell you, it can be really staggering how big of a relief it can be if you do something like that. And if you see that the problem that you're trying to solve there just is so hard to solve, try it with something else. And obviously the first choice should be a language that complements PHP, because you already have that on your tool chain. And last but not least, please stay in the PHP community, because I think it is a great community and it's a very powerful platform after all. So, thank you very much. I would say if you have some questions,